Hi, this is Coach Dorf again. We're going to look at an example of a problem that's like several homework problems. In this problem, we're trying to find out the exact trig value for the angle 2 pi over 3. So in other words, we're trying to determine the value of cosine of 2 pi over 3, sine of 2 pi over 3, tangent of 2 pi over 3, and the other three remaining trig functions. So first, let's do a review. In a previous video, I showed you a really cool way to remember the values of cosine and sine for the radian angles that are in the first quadrant. Those angles were 0, pi over 6, pi over 4, pi over 3, and pi over 2. Now, technically, 0 and pi over 2 are not in the first quadrant. They're kind of on the boundary, but those are important ones to know. And look at that video to make sure you understand, or you can remember what are the cosine values for all of these angles and what are the sine values for all of these angles. So either you can memorize that, or you can use what I talk about in the video to help you figure them out. And as just as a reminder here, if I were to think of these in terms of a unit circle, the angle 0 is right here. I haven't gone anywhere. So this is 0. If I do pi over 6, that's the angle pi over 6. I've gone that much of an angle. Okay, my circles are not not perfect here, but hopefully they'll help you. This is about the angle pi over 4. Here is the angle pi over 3. And the angle pi over 2 is this, which is a right angle right there. Okay. So first of all, you'll need to know what those angles, the values of cosine and sine are for those angles given there. Okay, now in this problem, we don't have one of those angles. Instead, we have the angle 2 pi over 3. And I ask myself now, which angle in that original group that we've written up above in the first quadrant is related to this angle 2 pi over 3? Well, it's really straightforward because I look at the denominator here, it's a 3, and the denominator here is a 3. As long as my function, my angle I'm trying to figure out is in reduced form, then I can just look at the denominators and say, okay, 2 pi over 3 is going to relate with pi over 3, just like this. All right. And we can remember from that video I mentioned earlier that the cosine of pi over 3 is 1/2, and the sine of pi over 3 is square root of 3 over 2. All right, so that's the first part. I'm going to use this pi over 3 angle to help me solve this problem. The second thing we need to do is, where is the angle 2 pi over 3? In fact, like, which quadrant is it in? Well, let's look at this again. If I have my unit circle, if I don't move it anywhere, that's the angle 0. If I go straight up, okay, this amount, I have pi over 2. If I go to the next line all the way over here, I've gone pi radians. And then if I go down here, this is 3 pi radians. And then the last one, if I go all the way around the circle, I get back to, or I get to 2 pi. Now, these are useful because these are the boundaries between the different quadrants. If I'm in this part, I'm in the first quadrant. If I'm in this part, I'm in the second quadrant. Here, I'm in the third quadrant. And here, I'm in the fourth quadrant. And what's useful with these is that I can figure out, I know what the X and Y values of numbers are in these quadrants. In the first quadrant, all right, X is always positive and Y is always positive. If I were to pick a number, a coordinate number like 1, 2, and it's in the first quadrant, I know that X is going to be positive and Y is positive. If I'm in the second quadrant, then x is less than 0, but y is greater than 0. In other words, x is negative and y is positive. If I'm in that second quadrant, which, let me highlight it here. This is the second quadrant. So anything in there, we have that x is negative and y is positive. If I'm in the third quadrant, that's this part right here, all right, I have that x is negative and y is negative. And last, if I am in the fourth quadrant here, then x is positive and y is negative. All right, so that's going to be helpful for us. Now, we still haven't figured out where 2 pi over 3 is, but I'm going to use these defining values. Again, we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And now, where does 2 pi over 3 fit? Where is it in between? Well, it turns out that it's in between these two, 2 pi over 3. It's between pi over 2 and pi. So in other words, we have that 2 pi over 3 is greater than pi over 2, but it's less than pi. And so that means the angle 2 pi over 3 is in the second quadrant. And in the second quadrant, the x value is going to be negative and the y value is going to be positive. Okay. Now, how does this relate with the angle pi over 3 that we talked about earlier? Here's the angle pi over 3. Well, it turns out that 2 pi over 3, we said, is related to pi over 3. They both have 3 in the denominators. 2 pi over 3 is over here. It's a reflection of pi over 3 across the y-axis. If I were to take my y-axis here, and if I were to take this and reflect it across here like there was a mirror, I would get over here, and that's 2 pi over 3. Why that's useful is, let me just draw it in here again. All right, let's look at the corresponding x and y values for these terms here. Okay, so for pi over 3, what I've got here is like a triangle. Let me make this green here, triangle here. And this triangle here, since I have a unit circle, the hypotenuse of my triangle is 1. And this angle here is pi over 3. This is the x value, if I'm just thinking about it as a graph. And this is a y value. Okay, because this is my x-axis and this is my y-axis. But if I think about this also in terms of trig functions, this tells me that the cosine of this angle, whatever it is, let me just call it a theta, its cosine is adjacent over hypotenuse, which is x value over 1, which just gives me the x value. So the cosine of the angle equals the x value. Likewise, the sine equals the y value. All right. So how can we use that now? So again, let's look at this unit circle. Here's pi over 3, that triangle, and here is 2 pi over 3. Well, what do I notice about this x value here and this x value here? Well, the distance or the length of the x value, they're the same, except this one, this is in the first quadrant, and so x is greater than 0, and here is in the second quadrant, so x is less than 0. But the value of them, the length of them, the absolute value of them is the same, okay? So in other words, because the x value equals the cosine, this is saying that the cosine of pi over 3 equals the negative of the cosine of 2 pi over 3. All right. Again, why do we get that? Because the cosine gives me the x value, and the length, the x value for cosine of pi over 3 is the same as the length of the x value for the cosine of 2 pi over 3. But the cosine of pi over 3 is in the first quadrant, so it's positive. The cosine of 2 pi over 3 is in the second quadrant, so it's negative. So I have that relationship there. All right. So that tells me then, if I want to solve this for cosine of 2 pi over 3, multiply both sides by a negative, and I get cosine of 2 pi over 3 is the negative of cosine of pi over 3, which is the negative of 1/2. All right. So in other words, we've just figured out that the cosine of 2 pi over 3 is negative 1/2. It's the negative of the cosine of pi over 3. And so as long as you've got that cosine of pi over 3 memorized, you can figure out the cosine of 2 pi over 3. All right, let's do the sine values now. So if I have my circle again, and here is pi over 3, and here is 2 pi over 3. Remember that the y value here is equal to the cosine value. All right. And what's in the first quadrant here, this y value is greater than 0. Over here, we have a y value. And notice that that y value, it's the height above the x-axis. It's going to be the same in absolute value as the y value in the first quadrant. It's the same height for pi over 3 and 2 pi over 3. All right. Now, in the second quadrant, what is the y value? Is it positive or negative? Well, in this case, it's positive. So the y value associated with 2 pi over 3 is the same as the y value associated with pi over 3. So in other words, the sine of pi over 3 is going to equal the sine of 2 pi over 3. It's how far, or what's the distance above the x-axis this point, these 2 points are, and they have the same height above the x-axis. All right. Well, and since we know what the value of sine of pi over 3 is, because of we've got that from that video I mentioned, or we've got it memorized, we can figure out what the sine of 2 pi over 3, because the sine of 2 pi over 3 equals the sine of pi over 3, and we know the sine of pi over 3 is square root of 3 over 2, and so that gives me then that the sine of 2 pi over 3 is square root of 3 over 2. Again, notice when I do the angle 2 pi over 3, I'm in the second quadrant, and in the second quadrant, the x value is negative and the y value is positive. The x value is associated with cosine, and we have here that the cosine is negative, okay, which is what we want. In the second quadrant, the y value is positive, and the y value is associated with the sine, and we have a positive sine value there because it's in the second quadrant. The y value is positive, so the sine value has to be positive. All right, so we've got those two trig values, but we have other ones we have to figure out too. We also have to figure out what is the tangent of 2 pi over 3, the cotangent of 2 pi over 3, the secant of 2 pi over 3, and the cosecant of 2 pi over 3. Well, we've done the hard work, really. We just now need to remember that the tangent of theta, of any angle, is the sine of that angle over the cosine of that angle. So the tangent of 2 pi over 3 is going to equal the sine of 2 pi over 3 over the cosine of 2 pi over 3. Well, we've already figured out what the sine of 2 pi over 3 and the cosine of 2 pi over 3 are. They were square root of 3 over 2 over 1/2. All right, now I've got a fraction. So just as a reminder here, when I have a fraction over a fraction, all right, I can simplify that by taking the first, what's in the numerator, writing it down, and then taking the reciprocal of what's in the denominator, which means we switch the order. So instead of having 1/2, I now have 2/1, and I multiply those together. These are equivalent. Dividing fractions is the same thing as multiplying by the reciprocal of the denominator. And when I simplify that, I get square root of 3. So this tells me that the tangent of 2 pi over 3 equals square root of 3. Okay. Oh, I made one mistake. The cosine of 2 pi over 3 is not 1/2, it's a negative. So I have to keep that negative there. And so I'm going to get a negative here and a negative there. So I have a negative answer. Okay, almost made a mistake there. Well, I guess I made a mistake, but I caught it. All right. What about, there's the tangent. What about cotangent of theta? Well, cotangent of theta is cosine over sine. But another way of thinking of it, and the way I would prefer to think of it, is 1 over tangent. So the cotangent of 2 pi over 3 is really just going to be 1 over the tangent of 2 pi over 3. And so I have 1 over what I just got, which is 1 over negative square root of 3. Now, I want to bring up a point here. Can I leave my answer like that? Can I have a square root in the denominator? Well, some of you are going to say, no, you can't do that because that's what they taught you in high school. Well, actually, you can. You can leave a square root in the denominator. There's nothing wrong with it. There's nothing mathematically wrong with it. Sometimes it's better to leave the square root in the denominator. Okay, that's not what they necessarily taught you in high school. All right, so I could leave that as the answer. If you didn't want to do that, all right, we could rewrite this as, so I have 1 over negative square root of 3. If I want to get rid of the square root in the denominator, I can multiply the top and bottom by that square root, and then I get square root of 3 over negative 3. So either answer is right here. They're both perfectly fine. Now, this is an important idea too, because the test that you will have during this semester will be multiple choice. And if they gave you the top answer here, this would be perfectly fine. But if you thought it had to be written like the bottom one, you might not be able to see that it could be the same as the top one. Likewise, maybe they would write the answer as the bottom one, but you got the top one. You have to be able to go back and forth between the two because they're not going to give you 2 correct multiple choice answers on the test. At least I certainly hope they don't. Okay, we've done tangent, cotangent. So now we have secant theta. What is secant theta? Well, that's 1 over cosine theta. So the secant of 2 pi over 3 is going to equal 1 over the cosine of 2 pi over 3. And remember that cosine of 2 pi over 3 we figured out was negative 1/2. So I now have, again, kind of like a fraction over a fraction. So I'm going to do that, I write the numerator down, and then I multiply by the reciprocal of what's in the denominator, which is this, and I get the answer of negative 2. And finally, cosecant of theta is 1 over sine of theta. So cosecant of 2 pi over 3 is going to be 1 over the sine of 2 pi over 3, which is 1 over square root of 3 over 2. And again, I'll write that as 1 times the reciprocal of the denominator, which is 2 over square root of 3. So I get an answer of 2 square root of 3, which is a perfectly fine answer. But if you wanted to, you could rewrite that. So you don't have a square root in the denominator. If you multiply the bottom and the top by square root of 3, and that would give you 2 square root of 3 over 3. So either one of these answers is correct for that. All right, thanks. Bye.